Okay, let's just dive right into this. You are about to face a deeply, deeply disorienting truth. Seriously, time travel is not just some fantasy reserved for late-night science fiction movies. It's not magic. It is happening right now. At this exact moment, as you're listening to me, your head is actually aging slightly faster than your feet. I know, that sounds completely impossible, maybe even a little absurd, but it is a fundamental, measurable reality of the universe we live in. Welcome to this explainer, where we're going to completely break down the absolute, proven science of time travel. We're stripping away all the Hollywood myths to look at the undeniable physics. And we're going to build this story in layers, starting from the laboratory-confirmed realities that we use every day, all the way down to the deeply forbidden paradoxes that literally threaten to break the universe itself.
Foundation of all of this, the reason your head is aging faster than your feet, is Albert Einstein's general relativity. Now, Einstein proved that gravity is not just some invisible magnet pulling things down. It's so much wilder than that. Gravity literally bends the fabric of space and time. Because of this massive cosmic curvature, the timeline isn't just some constant ticking clock across the universe. Time is entirely relative. Basically, the closer you are to a massive object, the stronger the gravitational pull, right? And the stronger the pull, the slower time actually moves for you compared to someone who's further away. So because your feet are physically closer to the center of the Earth's gravity well than your head is, time is literally moving just a tiny microscopic fraction slower for your feet. Mind-blowing, right?
And look, this isn't just some abstract chalkboard math. This is a laboratory-confirmed reality that powers almost everything in our modern world. Take the GPS satellites orbiting the Earth right now. They experience a genuinely measurable time difference compared to the clocks sitting down here on the surface. Because those satellites are way up there, further away from Earth's gravity, time actually ticks slightly faster for them. We are talking about literal fractions of a second, but it matters. If our scientists didn't program those satellites to mathematically correct for Einstein's theory of relativity, the navigation systems on your phone would completely fail within a single day. You'd be driving into a lake. We literally have to calculate for time travel every single day just to get accurate driving directions.
But gravity is only half the equation here. Special relativity adds another mind-bending layer to our understanding of the universe. It proves that extreme acceleration also distorts your progression through time. The physical law essentially dictates that as your speed increases, as you accelerate closer and closer to the literal speed of light, your subjective experience of time slows down drastically relative to the rest of the universe. Speed and time, it turns out, are locked in this inescapable cosmic dance.
To really grasp how terrifying this can be, I want you to imagine a scenario with me for a second. Imagine you board a highly advanced spacecraft. You buckle into your seat, the engines ignite, and you begin accelerating toward the speed of light. Let's say you're even charting a course near the edge of a massive black hole to take advantage of its extreme crushing gravity. The moment you do this, you are effectively leaving the standard flow of human time. You've opted out.
This extreme contrast creates what physicists call the twin paradox. Inside the ship, you experience what feels like a completely normal passage of time. You eat, you sleep, you read a few books. For you, maybe only 3 or 4 subjective years pass. But outside your window, the rest of the universe is experiencing time completely differently. Because you are moving incredibly fast and experiencing extreme gravity, the universe around you effectively fast-forwards. Centuries, literal centuries of Earth's history, unfold in what feels like an instant to you.
And this brings us to a really dark, terrifying personal consequence of this physics. When you finally turn your ship around and land back on Earth, you step out of the airlock having only aged a few years. But the harsh reality of forward time travel is that everyone you knew is gone. Returning home means facing a world that has aged entirely beyond recognition. You have successfully traveled to the future? Congratulations. But it is a strictly one-way ticket. There's no going back to the time you left behind.
Now, this exact scientific foundation is what makes those mysterious internet claims of an alleged time traveler arriving from the year 2256 so incredibly captivating to analyze. When people claim to be visitors from a distant future, the reason we even entertain the discussion, the reason scientists don't just immediately laugh it out of the room, is that the fundamental physics of traveling forward in time are mathematically sound. Skipping forward to the year 2256, that is entirely possible, provided you have a ship fast enough.
But here is where our explainer takes a massive, dramatic turn. While traveling to the future is an experimentally proven reality that, like we said, happens in our GPS systems every single second, making the jump backward into the past is an entirely different beast. Moving backward requires theories that stretch the very limits of theoretical physics and, frankly, test the boundaries of human comprehension.
Achieving a journey to the past theoretically involves a seemingly impossible two-step process. First, you would need to harness an unimaginably massive gravitational field, something far, far beyond anything humanity can currently generate. We're talking cosmic scales of power. Second, you would have to use that sheer cosmic force to bend the fabric of spacetime so severely that it literally folds completely back onto itself.
Physicists actually have a very specific term for these folded spacetime loops. They're called closed time-like curves. Think of standard time as a straight arrow, always moving forward from the past to the future. Well, a closed time-like curve takes that arrow and violently bends it into a perfect circle. If you were to travel along this circular mathematical path through the universe, you would eventually end up at the exact same point in space and time where you started. You would effectively return to your own past.
Now, what is truly staggering, what really keeps physicists up at night, is that the brightest minds in history have proven this concept actually works in the math. Theoretical models absolutely allow for past travel. The great mathematician Kurt Gödel actually developed a rotating universe solution using Einstein's own equations to prove that time loops are theoretically possible. Other physicists have proposed traversable cosmic wormholes, which would basically act as temporal shortcuts through the fabric of space. There's even the concept of an infinite Tipler cylinder, which is this massive spinning tube that drags space and time around it like a whirlpool. The crazy part? The math actually works.
However, this creates a massive, escalating tension in the scientific community. We have this profound conflict between what our physics equations beautifully permit on paper and what the actual physical universe allows in reality. Because, let's be real, just because an equation balances out perfectly on a chalkboard does not mean the cosmos will tolerate us actually building it. And the main reason the universe might fight back against backward time travel is due to the catastrophic, universe-breaking consequences of altering history.
The moment a traveler from, say, the year 2256 steps into the past, they trigger genuinely forbidden territory. The most famous example of this is the grandfather paradox. This is a temporal contradiction where a traveler goes back in time and, either accidentally or intentionally, does something that prevents their own grandparents from ever meeting. Now, if their grandparents never meet, the traveler is never born. But wait, if the traveler is never born, they could never go back in time to alter the event in the first place, right? It is an infinite logic loop that literally threatens to break the fabric of reality.
So, the absolute crucial point here is how the universe handles this kind of error. If we live in a single collapsing timeline, a paradox like that could, in theory, destroy all of existence. Just wipe it out. But to avoid having the timeline collapse under the weight of these contradictions, quantum physics offers a brilliant alternative called the many-worlds interpretation. This model suggests that every single time a temporal change is made, the universe doesn't break. Instead, it simply spins off a brand new parallel universe. You don't overwrite your own past. Instead, you create a branch. You alter a parallel reality while your original timeline remains perfectly intact, completely out of your reach.
Yet, even with parallel universes acting as a sort of safety net, many physicists believe the universe has built-in cosmic defense mechanisms to stop us from messing with the past altogether. The brilliant Stephen Hawking proposed the chronology protection conjecture. This essentially states that the laws of physics will always conspire to prevent backward time travel. It's like a cosmic firewall. We're forced to consider whether these quantum mechanical barriers are absolute, or if creating a time loop merely requires exotic negative energy scales that humanity simply cannot yet comprehend. Maybe we're just not advanced enough yet.
Which leaves us staring at the final piece of this immense puzzle. When you look at all the mathematical possibilities, the traversable wormholes, the infinite cylinders, the parallel branching timelines, we are left with this deeply haunting realization about the empty skies above us. Think about the sheer expanse of the future ahead, millions of years of potential human progress. If time travel to the past truly becomes a reality at any point in human existence, we are forced to wonder why our present isn't entirely flooded with tourists, historians, and visitors coming back to observe us. I mean, where is everyone? The silence from the future might just be the greatest mystery of all. Keep seeking the truth, keep questioning the fundamental nature of our reality, and I will catch you in the next explainer.